Hello friends, welcome to Electrical Design Engineering YouTube channel. You have ever imagined what will happen if motor tries to restart after a sudden fault? What are the factors which decide whether motor restarts smoothly or not after the sudden fault or sudden disturbance? What are the problems arise when all motors connected to the system tries to restart after a disturbance? In this session, we will break down the key factors that affect the motor restarting, the challenges industries face during re-acceleration of the motors, and how the tools like ETAP help us to predict and prevent these issues. Before starting the lecture, I have a small request to you. Please like, hype the video and subscribe the channel. I will ask you a question whose answer will be in this lecture. The question is the critical fault clearing time represents. You have four options. The option one is the time a motor takes to accelerate fully. Option two is the maximum time within which the fault must be cleared to avoid instability. Option third is the minimum time needed for a protection released trip, and option fourth is the time after which the motor torque becomes constant. Faulted motor transit analysis. It is also called the motor reacceleration analysis. The primary goal of every industrial electrical power system is to have minimum shutdown time after any disturbance, so that the industrial process is least affected and the production loss is minimized. The motors are backbone of production. Even a small disturbance can stop motors, and if the motors stop, the industrial process stops. This leads to production loss. So it is important to design the system in such a way that motors can quickly recover and restart after a fault. First of all, we should understand what happens when fault occurs. When the fault occurs, suppose at the motor bus or at the motor terminal, the bus voltage becomes zero. As the motor torque is directly proportional to the square of the voltage, so if V is zero, the motor torque becomes zero because motor torque is directly proportional to the voltage. As the voltage becomes zero, motor torque becomes zero. This means during the entry fault duration, the motor is producing no torque. I mean, motor torque is not producing during the fault duration. What is the effect of zero motor torque? As we have seen that during the motor fault condition, the motor is not producing the motor torque. What is the effect of zero motor torque? Now the situation is motor torque is zero, but the load torque is still acting on the shaft as motor has not stopped due to its inertia. This means the load torque is greater than the motor torque and motor will start to slow down. This slowing down is called the deacceleration. Now suppose the fault is cleared, voltage is regained, voltage comes back. As the voltage returns, the motor torque also starts recovering. Now the motor tries to accelerate and tries to reach to its original speed, but whether it can recover or not depends on three things. One is how long the fault lasted, that is how much time it protection system take to clear the fault, that is the fault clearing time. How heavy the load torque is, that is how heavy the load is, and how quickly the motor can build up the torque again. These factors affect whether the motor can recover or not, whether the motor can accelerate or not. If the motor can produce enough torque quickly, it will successfully recover. If not, it may stall. If the fault clearing time is short, motor does not lose much speed, so motor reaccelerates easily. But if it is long, more fault clearing time. Fault takes more time to clear. The motor speed falls more. Motor requires more torque to recover. Recovery may fail if motor torque does not rise above the low torque and motor will stall. So we say low fault clearing time is good for the motor acceleration. In industries, especially in oil and gas or large process plants, even a small shutdown is not acceptable. So industries use an automatic system called automatic motor restarting system. The aim of this system is that after a voltage dip or a disturbance, motor should automatically restart within a set time. Sometimes motors are started in a planned order, one by one, to avoid high inrush currents. Also, sometimes non-critical motors are tripped off to reduce the load and help critical motors recover. When a group of motors is restarting together, the system voltage must not dip below the certain limit. If the voltage drops too much, it will disturb other running motors and may cause further instability. So the process is carefully designed to keep the voltage between specified limits. Why we perform motor reacceleration studies? The aim of the performing motor reacceleration studies on ETAP is to evaluate whether motor in an industry or a power system can successfully restart and recover their speed after a fault or a voltage dip without causing system instability or shutdown. Thank you.